Thank you, Robert. For the one present last year, be very attentive because it's the last year I will make this presentation, of course. I will change of subject next year, I assume. Quickly, what do we do, or what do I do, because Alterline is very small. It's providing a strong technical expertise for both co-processing of pre-processing. I say technical because I don't do waste sourcing, for instance, but we have partners who can propose it. There is that. There are other people in the room. Including also safety issues. We developed specific auditing and risk assessment system for alternative fuel and waste on demand and together with a cement producer, which is actually Achium, so member of the CRH group. Why provide strong technical expertise? Because not all the plants or the producer have a large experience. Some group have their own department with enough knowledge, okay, Just Cycle, Axel is there, with Michael Inkel, but not all companies are so big, and not all companies have enough plant to share the experience. The experience is the base to avoid project failures. There are a lot of success, but there are also a lot of failures in the AFR projects. For who, I said all AFR stakeholders, basically cement producer producing or not their own fuel, fuel producer, so some new trend. I have a client is now producing fuel, but sell it together with technical services and support for investment for the feeding lines, for instance, and also associations like GIZ or European Community. All we do, so I said Alterline is small, so basically I'm no employee, but I work together with partners for the different contracts depending on the contracts. Both are experts with a long and proven track in the industry, so there are no born consultants in the team. I work in Algeria currently with François Vallet, which was plant manager and Just Cycle manager and technical manager in Holcim. For another contract, I worked with a specialist of the maintenance, also previously head of maintenance, so a lot of ex-colleagues, but we are both experienced in the industry. So, alternative fuel can have positive and negative impacts, of course. If there was no positive impact, nobody would use it. I will focus on the kiln process impacts, which have also impacts on environment, clinker quality, and equipment. Both are together. You have to maximize the positive impacts, increasing the gross added value, or I will speak about it a bit. The net added value of the alternative fuel can be the gate fee, can be it's always the substitution, and then a combination of other factors, but you have to mitigate the negative impacts. The limiting factor for using alternative fuel depends on each plant specifically. Of course, it depends a lot of the type of kiln. If you have an old wet kiln, it will be a completely different impact than if you have a calciner, a modern calciner kiln. And I will repeat it a few times during the presentation. One of the rules is not starting alternative fuel if the kiln is not under control and if the basics are not acquired. So it's something to prepare. Basically, the challenge are the more difficult fuels compared to traditional fuel. I speak here about, let's say, traditional alternative fuel, not about very high calorific spent solvents or waste oil, of course. The impact on the kiln process will be an increased heat consumption, higher exhaust gas volume, which is also partially a consequence of the increased heat consumption, a higher input in chlorine, typically, and change in the kiln operation and behavior. And there are potential consequences. It can reduce the capacity of the kiln, it can reduce the availability of the kiln, it can reduce the quality of the clinker, it could generate higher emissions, and of course the target is to mitigate this negative effect, or even to compensate it. That's the point. What are the factors impacting the kiln? If you compare basically alternative fuel to traditional fuel. Traditional fuel, I think, to coal or petcoke, typically. First, the water and the ash are generally higher in the alternative fuel than in the traditional fuel. Secondly, the poor combustion, which is partially caused by the lower calorific value, the higher water content, and the delay ignition often, and by the particle size. The cold air, you will have some more pneumatic transport, or if you have no pneumatic transport and a mechanical feeding, you will have some extra false air. It will bring cold air in the system. The thermal input fluctuations, it's difficult to feed very smoothly alternative fuel. We will see it's really of major importance. You will have fluctuation in both calorific value, but probably also in the throughput. It's not only small fluctuation, it also includes the stop of the feeding because of a breach, because of clogging of the pipe, because we will come back on it. And then the circulating elements, so mainly the chlorine, since if you use petcoke, and especially high sulfur petcoke, probably you will decrease the sulfur input of the kiln. The classification quickly of the alternative fuel, you can classify it by physical properties, let's say liquid, sludge, solid, or you can classify it by feeding points. Liquids, let's say, if there are no particles in the liquid, it's not a big deal to inject it. It can be done at the main burner or at the calciner. Depends on the liquid. Lump fuel is fuel which is too big, too heavy to be suspended in the calciner. Of course, you cannot move it pneumatically, so it will be put at the kiln inlet in a limited way, let's say, limited substitution to avoid reducing conditions. It's like full wool tires, filter cakes. You will see it during the visit on Friday for the one doing the visit in Lix. They have some filter cakes at the kiln inlet. If I'm not wrong, they move it from the calciner to the kiln inlet. Coarse solid, I mean solid with three-dimensional particles, 50 millimeter up to 100 millimeters, depending on the orifice speed, the calciner design, and 2D material, 200 millimeter sheet, can be higher depending on the handling equipment. That's for calciner. It's coarse solids, typically tire ships, coarse SRF, this type of product. Shredded wood, really depend on the calciner design. I mean inline calciner. And then fine solids for separate line calciner or pneumatic, so main burner, pneumatic injection. That's basically below 5 millimeters for the 3D particles, and 2D particles can be 20, 30, 50 millimeters. I have sometimes a quite different opinion than some SRF suppliers I heard earlier. To my opinion, the really good fuel for the main burner is mainly to have light material and avoid 3D or heavy particles, much more than the size of the 2D particles, which has finally low. It doesn't make really difference if you have sheets of 20 millimeters or 30 millimeters or 35. So the first impact will be on the thermal consumption, mainly due to the water and the input of fresh air in the ozone, and the increase of oxygen, because since you have some fluctuations, you need to increase the oxygen at the kiln inlet. It means you will have more gas and you will increase the consumption. The two big factors in this tree are water and increased oxygenation. The impact on the flame temperature, it's of course depends on the kiln. If you have a short kiln with 40% thermal input at the main burner, the impact will be much faster than if you have a long wet kiln with a huge consumption and only the main burner. The problem is typically linked to the water content and to the particle size, because if you have big particles, you will increase the flame length to avoid the particles falling in the bed, and then you can have too low flame temperature, among other problems. The kiln capacity, the impact on the kiln capacity. If the treatment of the off gas is the bottleneck, basically the ID fan capacity, and if the ID fan is the bottleneck, so you increase the heat consumption, so you increase the flue gas flow, basically, also the water you inject and so on, oxygenation, so you will decrease the maximum capacity of the kiln. If it's not a sold out market, let's say in Europe in 2015, for instance, it was no problem at all, because the kiln were not operating at the maximum. They were not at the BDP. So that's not a problem. But if you are in a sold out market and you sell everything you can produce, then you have really to take into account the loss of production capacity and to mitigate it or to compensate it. The impact on the kiln availability, basically maintenance, like corrosion problems, refractory expansions, and on the other hand, due to the chlorine increase, more buildups, less stable coating, so risk of falling. Globally, you need to increase the maintenance. The impact on the kiln behavior, mainly due to the change in the flame. You increase the flame length if you work at the main burner, so you will also have a slower reacting kiln with impact on the measurements, you have to know it. The impact on the emissions, typically you can increase or decrease SO2 emission, because you will, if you have big fluctuation, you will have reducing condition from time to time, you will have SO2 peaks, but you can perhaps also improve it by switching from petcoke to alternative fuel. You will reduce the NOx typically. And be careful, one important point, never put material containing volatiles at the kiln inlet, cold sides, because you will just find them at the stack. Something also about emission. Generally, we don't speak about the fugitive emissions. With the development of SRF, I think it's of major importance. I don't know how many plants I've seen with a lot of plastics everywhere. If you install a feeding line, especially if it's windy, think about the fact that a standard belt, you can cover it what you want, it will never be tight. It means you will always find some plastics everywhere. Yeah, something is wrong. Okay, impact on quality can be reduced, clinker. At a certain level of alternative fuel, the ash volume and the ash composition start to be very important, especially with dried sludge, for instance, ashy fuels. And you need to compensate it by preparing the raw meal correctly. So it's important to keep in mind. All these impacts have cross effect, as I said, thermal consumption, then kiln capacity, then if you have higher velocity in the tower, you have more buildup also, and the buildup also increased by the chlorine and so on, so it's quite complex. It doesn't make your life easier, but more interesting. It's not from me, it's from Michael Winkel, who made a nice presentation previously, and who was a colleague, but I think it's completely true. So, basically, because I'm always too long, higher is the complexity of the process. It's true for cement, you know, it's true for alternative fuel, of course, it's true for any industrial process, I think. More is it complex, more you need stability. And stability, in terms of alternative fuel, it means stability of the thermal input, so both stability in the calorific values and stability of the throughput. It means stability in the ash input and composition above a certain level, of course. If you are putting something like 0.05% ash on the clinker, you don't take it into a consideration. And stability in both oxygen profile and temperature in the kiln. So it's always fighting against a trend in the operators, which is really challenging the throughput and going to the higher value during 5 minutes or during 1 hour. That's not the idea. The idea is to keep the installation available and to maximize the average throughput without too much fluctuations. So, again, starting alternative fuel co-processing is not just adding a feeding line. If you start like this, you have a quite high chance of failure. It's really an alternative fuel development process. It includes the feeding lines, but it's not only the feeding lines. And ideally, you should start the development before buying the feeding line. You will save reputation, you will save time, and you will save money, that's for sure. Some keys for the success, I told it already, you start only with a kiln which is under control. That's not really my job, but it's really of major importance. You make a study about the available alternative fuel before starting to build a line. That's the second cause of project failure. You don't build the right line for the available alternative fuel, or even you don't find alternative fuel, or it's too expensive. So that's something very important to do. Train the management and the people of the plant before starting the co-processing, that's also of first importance. Knowing that there could be impacts and what can be the impacts, knowing how to mitigate the impacts, how to analyze what they see. Training the people for sampling alternative fuel, it's more difficult than sampling cement. Of preparing, analyzing alternative fuel, you know. Some studies were made in Holcim group when I was in Holcim, and only 5% of the problem of the error of analysis of alternative fuel were due to the analysis. It was mainly sampling, 55%, and preparation of the sample, 40%. And there are a lot of plants with a very nice alternative fuel lab, and they have SRF and they have no lab shredder. So they cannot prepare anything correctly, and they cannot sample adequately the material to have something representative. So you really need to make it with a systematic and pragmatic approach. Developing the adequate management system. Also, don't start co-processing if you don't have developed a reception, an acceptance procedure for the alternative fuel, a reception procedure for the alternative fuel, analysis procedure, everything around it. You need the quality control of the alternative fuel, but probably you need to increase the quality control also of the clinker. you need to measure the circulating element in the hot mill more often. This type of step has to be done before. Another key is starting to the inline calciner when you have an inline calciner and when it's modern enough, because it's less sensitive to the fluctuations. You know, it's a flameless combustion if you don't have a separate combustion chamber, of course. You can have a mechanical feeding, so you can feed much coarser alternative fuel, so you will not pay the same, that's it. You have the tertiary air, which contains 21% oxygen by definition, so it's let's say easier, but you need a good velocity at the orifice and enough residence time. Consider the specific local condition. I said it at the beginning. Each plant is different. The geometry of the calciner or the main burner type, if it's a main burner, the raw mill properties can vary a lot from one plant to the other. The characteristic of the traditional fuels, it's also perhaps something you will need to improve. The potential alternative fuel candidates and their properties. And often what you do is you compare with existing plant. Eventually you make a CFD. I think CINAR and XRG are here. And when possible, it's always my preferred solution, you make some trials. But then you need already a feeding line, of course. Estimate the impacts on the kiln to know what could happen. It's just a short example. I will not stick too long on it, but it's just to show that it could be major impact. If you put only 10% of low-grade fuel at the main burner on a preheater kiln, I mean low-grade SRF, like 30% of water, 50% of ash, you will tell me, it's an ugly SRF, but it's not so ugly. There are much worse ones in Egypt, for instance. If you don't make any mitigation, you will consume 20% of your SRF just to compensate the thermal consumption increase, and you could decrease your production by between 4 and 5%, let's say. It's huge if you are in a sold-out market. So you need to do something. So another key, it's what I say, you need to be based on the experience and to share the experience with the other. It's not only theoretical. You know, with SRF, the first projects were mainly problematic everywhere, whatever the supplier. Because it's bridging, it's sticking, it's elastic. You can have auto-consolidation. I'm sure Luigi Di Matteo will speak about it. He always speaks about it. You can have foreign body, you can have long strips. And you see there are a lot of examples of problem clogging. Some of you will recognize that plant. 5 minutes, it's short. So, to consider it, you make the good design. If you have that in your plant, it will never work. That's an example. That's something we dismount. Improve the maintenance, first importance also. Predictive and preventive, because you have to avoid the fluctuation. It means you have to avoid the blockage of the feeding lines, both pneumatic or mechanical. Fight against the false air, it's always important, but it can help you to compensate the loss of production related to alternative fuel if you need. And anyway, it's a good practice. So don't do this, go for tight system. Optimize the process and use the good AFR tools. If you don't have it, source it externally. Use process cards, make Pareto, debottleneck the existing line step by step, and always question the most cost-effective solution. Also with the preparation with the alternative fuel. Or you can improve the kiln, or you can improve the fuel. Both are always possible. Yeah. So typical optimizations. So low cost, let's say, improved waste selection, low capex, I mean. Improved waste selection, optimize the pre-processing, optimize, that's mine, you see. Optimize the quality control, the handling and the feeding of the waste, the cooler. You need some tools for optimizing the cooler, the burner, everything. Optimize the backend, oxygen measurement, and so on. The instrumentation is always of first importance. If you want to modify, you can put a new kiln inlet analyzer, you can improve or put a new pre-processing, a new burner, change the refractory, increase the kiln. That's for the kiln. For the tower and the calciner, okay, basically you maintain everything. You increase the quality control, you increase the hot meal analysis. You can change sometimes the feeding point, be sure the tertiary air damper is working properly, and so on. And as modification, then you start generally with higher capex. You can upgrade the calciner. You can put specific equipment. You can upgrade the alternative fuel handling. You can replace the cyclone or take low pressure drop cyclone. There are other risks with it, but you can increase the preheater cleaning system. Is typically put analyzer of oxygen. It's always easier. Envisage a bypass or hot meal extraction if you have no money for a bypass. So, shortly, I said first regularity and stability. Secondly, all the potential impacts can be controlled if you do it correctly. Perhaps you will not go to 100% substitution, of course, but you have to estimate the impacts and to control them. Do not start co-processing if the kiln is not stable. Develop the adequate management system, procedures, and train the people also. Start firing up the calciner. Make the sourcing before starting your project, but I think everybody knows it. Nobody does it, but everybody knows it. Simple is beautiful. Don't try to reinvent complete, make rocket science. Less equipment, less trouble, let's say. Maximize the operating time, minimize the fluctuation, and start always with the low capex solution for the optimization. For the feeding line, you need to pay the price. If you put shitty equipment, you will have only shitty clinker and shitty problem in the plants. I have a lot of clients trying to buy on some local market in Asia and so on, and for both pre-processing and co-processing, it doesn't work until now. Probably there are some good suppliers, but I don't know them. But so pay the price to have a good feeding line, but make really a big alternative fuel development program and not just feeding line. That's my message. And start step by step. Thank you.
So thank you very much indeed, Stéphane, for telling us like it is and not sugaring the bitter pill that can be alternative fuels use. We have a couple of questions. We have time to ask them, so let me just... so the first one is from Marcus Stamfley. What is the potential of adding alternative fuels when a satellite... what is the potential of adding a satellite burner?
A satellite burner?
I think this is a separate burner. That
you mean a separate combustion chamber?
Separate
above the main burner, pipe.
I would. My advice I give to some clients, I told them, okay, you should try it. I have one experience, you have probably the same, because it was an Holcim plant, and no, it's a CRH plant, it's in Emeng. We said, okay, we will first add the satellite burner, and then if it doesn't work, we will change the burner, and finally it was working very well. But, okay, the throughput is the substitution with the SRF is still relatively limited in this lamp because it's a local kiln and the quality is good. To my opinion, I think it's good. Also, when I discussed with Xavier Dubert, he's not here this year, but it's a specialist in the burners. He made a presentation last year. He told me that the last tendency currently was to add satellite burner on the new burn. It's quite fluctuating. Previously it was not good. No, it's good again. Honestly, I would say I would not buy a new burner without testing it, because of the cost. You put the pipe, you put the concrete, and you see. What I would probably not test it, it's something I've seen in Barcelona during a visit. I don't know if here is trying to make a kind of satellite burner, but inclined to have some ballistic flight of the barrier. But okay, I cannot answer better than this, sorry. But I know it's working in some plant, and I would start with it.
Okay. In fact, we had a couple of other questions again from Oliver Quantz, but we've run out of time. So if you'd like to have the answers to those questions, please address Stéphane directly. But let's thank him once again for his excellent presentation. Thank you very much, Stéphane.